is 7th of the 12th. Now we can draw, right? Instead of doing f cos f sine theta, instead of doing like we've been doing, not going to do any more of that now, right? When we've been doing that, and we've been doing, you know, f cos theta and that type of stuff. F1 is there and F2 is there. Right, that's the maths way of doing it, analytical way of doing it. Right, analytical. Oh, laugh. Analytical. We've also got to be able to do it scale drawing. We've also got to be able to do scale, right, drawing, which means you need a ruler. This is what I said last week, right? Because you can't do it without a ruler. So we need a ruler. Obviously, it's quite hard to do this face to face. Sorry, not face to face, but you'll need a ruler because you've got to scale it. I would suggest you do it really as well on graph paper, although you don't necessarily need graph paper. And you need a protractor. For drawing angles. Right. I would suggest, yes. Well, you could definitely need a ruler. Protractor is definite because there'll be angles. So have you all got a protractor that you can put your hands on today? Have you got a ruler you can put your hands on today? As in now. It's quite hard otherwise. Graph paper, it's easier on graph paper, but you can do it on plain paper if you want to. Right. So if you've got a ruler, right, but you'll definitely need a protractor for measuring angles. Is Jake back yet? You back, Jake? Is the computer working? Jakey! Isn't Skyped off, does he? Right. So we'll just go back over a bit. We'll just go back over something we would have done last week. Oh, sorry, not last week, last year. So page 2. Right. So scale drawing. Because we can draw them, we can make, you know, 10 kilonewtons, we can draw them as a scale. So we'll just go over what we did last week. Not last week, sorry, I keep saying that, last year. Start off nice and easy, right? If I've got, this is Oliver Booth, right? That's Oliver Booth there, right? That's Oliver Booth. Now, I'm going to have to sketch it, right? But I'm going to have to sketch this, guys, right? But make sure, if you haven't got a protractor with you, just make notes, because it doesn't really work unless you've got one, right? But I can't really do it on here either, so you have to bear with me. This is Oliver Booth, right? Oliver Booth, he's being pulled that way, right? 20 newtons. And he's also being pulled this way at, let's say, 40 newtons, right? Right, and the angle in there is, I don't know, 60, say. So these are just forces. They could be force in a pin joint, right? But it's stuff that we covered last year. We'll just go back over a little bit. We need to work out, right? That's Oliver Booth. He's been pulled that way. Sam Houston is pulling him that way at 40. He's been pulled up by Cameron Davis when his arm is fixed 60 degrees at 20 newtons, right? Somebody draw on here, which way is he going to go roughly? Don't make a big mess, just roughly on there, which way is he going to go? Just draw a line. Somebody. Just. Yes. Okay, sort of, yeah, he's going to go that way, isn't he? Right, he's going to go closer to the 40, so he's going to go somewhere like, something like that. Right. Now we could work that out, doing a bit of maths, but we've done that, so we haven't got to do it again. The way to do this, as in scale draw it, as in to draw by scale. Right, that's what we do. Right, he's going to go something like that, like Kieran said, right? So what you would do is you would draw, right? You would make a scale. So I'm going to say, let's say, I don't know, 10 Newton, right? So I'm going to draw, right, is 1 centimeter, say, if you like centimeters. So to scale draw this now, right? What you do is you draw this, you draw a straight line. Equivalent of 40. It's going straight. It's going straight, right? So you would draw with a ruler. If you've got graph paper, it's easier with graph paper because you've got straight lines on the graph paper, right? It's got to be straight because it's going straight. So I would draw a line, straight line, to represent that 40. How long would it be? How long would it be? Well, I got 40, so it's going to be 4. 4 centimeters or 40 mil. It's up to you. Right? It's got to be to scale, so it could be 4 miles, it could be 4 kilometers. As long as it's 4. Does it keep crackling, is it? Is my voice crackling for everybody else? Oh my God, oh my eyes. Oh. Is it like annoying crackling? Quite bad audio sometimes. Oh. Wait there then. I am on my 4. Right, let me just. Hold on. I'll just stop. So I'll go for my microphone then, and I'll go on my iPad right there. It just means the recording of this won't have any sound, right? I don't think. Let me just hang on. If I do this, hang on. Wait there. If I unplug that, no. Then. Cool, right. So, if I can do this then, see if I can record. It's quite handy to have recording in it. Start recording. Can you hear me? Can you hear me? Can you hear me? Can you hear me now? Yes. Okay, cool. My laptop, my laptop can't connect to the internet for some reason. So I've got my own BT dongle, which is only picking up the 4G. So, but I'm on thing now. Dongle. Funny word, dongle. Right. So, this is still going. I might just be a bit quiet now on the recording, but right, here we go. So you draw 40, right? You would draw 40, and then you'd add on the 20, right? You'd add on the 20 on the end, top and tail. So you would draw 20, right? Something like that, right? Off to scale, and the angle would be, what would the angle in there be? What's the angle in there going to be? Well, it's going to be 60, right? So you'd have to put your protractor on there and draw 60 up. And then draw a line, 20, right? 2 centimeters. Right, because we're doing 10 newtons as 1 centimeter. Right, so we're just adding, basically we're just adding on like that. Look, that's easy, we're doing it. That's what we're doing. And the resultant force, because we're trying to find out, the resultant force would be where you would get a line and you would draw it from there to there. That would be the resultant force. Right? And you would measure that. You'd measure it. And you'd also measure the angle. And that would give you, so whatever the force is, so Oliver Booth. So Oliver Booth, hang on, what's going on here? Oliver Booth, right, so resultant force equals, I don't know,
58 newtons at 23 degrees, something like that. I don't know what it is because I haven't drawn it. Scale drawing, right? So you've got to get the scale right, and you've got to get the angle right. If you haven't got a protractor, you can't do it. You're stuck, Ali. Jake with us. Jake with us. Jake back. Right, so is everybody all right with that? A bit last year, and I'm just making sure that we remember a little bit. But you need a ruler and you need a protractor. If you haven't got a protractor, you can't guess these things, right? So if I had the same thing, if I had Cameron Davis, right? Because he can't move his arm. So if he was pulled that way, 7 newtons, and he was pulled this way at, I don't know, 2 newtons. The angle in here, let's say the angle in there is 90, let's say it's 110. Don't know that. We need to work out which way he's going to go. Right, we're going to draw that. Which way is he going to go? All you really do is, this is called, right, the space diagram, but all you do really is we're going to add this 2 onto the end of that, really. All we're going to do is just, so we finish that squint. So what you do is properly scale draw it. We'll do 1 centimeter equals 1 newton. Pick scale, see, huh? Nice and easy when you got 7 and you got 1s, right? So obviously I would draw that 7 first. I would draw my 7. How long would it be? Well, it's going to be 7 centimeters. Straight, which is a straight line. Right? So graph paper's handy because it can be straight, right? And then I would add on the 2. Right? I would add on the 2 to the end of it. Now I would measure. I would get a protractor and I would measure 110. I'd put my protractor on there like that. I'd obviously put the main bit on there, but 110. So it's going to be obvious, right? So you'd measure 110 because it's 110 degrees. Then we draw that line up. How long will that line be? Well, it's going to be 2 centimeters. But the angle in there would have to be 110. Or you could go from the other way, couldn't you? How much would it be from this side? If you're going to go here, what would it be in there? You should all know that, really. That's not a difficult thing, is it? Obviously 180 in it. 110, 180, right? So that's going to be 110 in there. You draw that line like that. And the resultant force would be from here to there. Obviously, because it's going more in the 7 direction than the 2. So okay. That would be your angle in there. You'd have to draw that angle. So you measure that angle and measure this, whatever that would be. I don't know if anybody's got a protractor. Anybody doing this as I'm going along? Right, but you need a protractor. If you haven't got a protractor, it's quite hard to do it because you can, although we can sketch it until you've got the angles, we don't know. But is everybody getting my drift? It's not new to us, right? Is everybody getting my drift so far? Type a dot if you're getting my drift. Type a dot. A dot. What type of dot? Okay. No, Jake. Where's Jake? Jake? Skype off now. Hey, Jake. Right. So we could also do this. We could also have it. We could also have it something like this. That's my data line. Also have, who's next? Ethan Thomas. Ethan Thomas there. He's been pulled this way. 6 newtons. But this one, right, he's 30 degrees in there, right? The same problem, you just got to make sure that 6 is 30 degrees up. He's also being pulled that way, say, at 10. And let's say the angle in there is, I don't know, what do you say? I don't know. Let's see. Well, that in there, let's just say that one, right? So what we'll do it in there. We'll do the one in there, because then it makes it a bit easier for us, because we know then the angle that we got to draw to. Right? Let's say the angle in there. Let's say that's, I don't know, 80 perhaps. 80 in there. Right, it's from that line there, boys, right? It's not from the horizontal, it's 80 there. Right? 120 all in all, right? But what you do the same thing. You would do the same thing. You'd have to draw a scale, 1 centimeter, 1 newton. And then you'd start off, straight line, draw the 6. So you'd have to measure 30. Right? So you would measure 30 in there, draw 6 centimeters, right? And then the 10 and the 6, right, they're 80 degrees apart. So what you do is you put your protractor on there, like that. Don't put it straight like that. Put it on there like that and measure 80 degrees. This in there's 80, and the 6 and the 10 are 80 degrees apart. So you measure 80, right? Put your protractor on the line. Put this out somehow now. Are you with me with that one? Always don't stick it straight like that. You've got to put it on the actual thing. So you'd have your mark 80 degrees, and then you draw your line. How long's your line going to be? Well, about 10. Not to scale now, right? So 10 centimeters. Obviously, it doesn't look right now because of my 6, right? But you would do it a bit better than that. And the angle in there should be 80, yeah? And the resultant force, then you would just join up as normal. There's my resultant force there. So you'd measure that resultant force, and then I would also measure the angle from there, from horizontal. From horizontal. That's just 2 forces now, right? Everybody right so far? Nothing new. You just need to get a protractor. If you've got a protractor, you'll be up stuck. Everybody all right? Everybody all right? Talk to me, Goose, as they say in Top Gun. Page 1, page 2, page 3, page 4. Now you may also get something like this. So we may have, who's next on there? Sam Houston. Have I done Sam Houston? Because somebody else. Sam Davis. Oh, Sam Houston is that there is Sam, right? And Sam is being pulled this way. He's being pulled that way. Or that way. 3 forces now, right? It's the same process. They're just forces. They could be forces because this could be a pin joint. This could be like this. This could be one of our pin joints, like we've been doing. We could have a force going that way and a force going that way in an angle. Same thing. Right? Just a bit of practice just to get you back into the scale drawing mode. So obviously I need to give you some numbers. So this could be, I don't know, 6 newtons. This could be 3 newtons. And that could be 4 newtons. Let's say the angle in there is 40. Okay. And the angle in there looks 90 to me. Let's call it 90. It's in there and it's in there. We need to work out which way is Sam going to go, which direction, what angle, and how much force is he going to be pulled in what direction, right? So you could roughly guess, I suppose, because you've got 6 and 3 going that way. But what you would do is, same as before, we've got 3 things now, right? So this is what you'll be doing. Do your scale drawing, scale, let's say 1 Newton is 1 centimeter. 10 millimeters is up to you, next thing. So we'd start with a 6. 6 is going straight, so you draw the 6 straight. So 6 newtons, so 6 centimeters. 6 centimeters is going straight. Keep it straight. And then I need to measure 40 degrees. We'd measure 40 degrees. This is 40, and then I draw my 3. So 3 would come up something like that. Not as much as that, perhaps. But once you've got a ruler and you're doing things, it'll be all right. That's going to be 3 centimeters. All right. 3 centimeters. Just want to make a bit of room for the 3 centimeters. 3 centimeters. And then I would then put my protractor or my angly drawing thing on here. I would then put my angly drawing thing on there, right? What would I measure? What would I measure? Somebody tell me what would I measure? What would I have to measure from here? I'm going to draw the 4 now. I'm drawing the 4. And the angle between the 3 and the 4 is, let me scroll down because I can't see the answers. 90 degrees. So you put your protractor on there. Don't put it straight like that. Don't do that and draw 90 up here. Right? It's not going that way. Just there's my 3 and the 90 degree is here, say. Then you would draw that. You would draw that, and it can be any color we want. It's going to be a bit smaller than that, but there we are. It's going to be 4. It's 4 newtons, centimeters. And then the resultant force would be that. That's the resultant. And the angle would be in there. Everybody all right with that? You would do it? Yes, you did it last year, Kevin. Yes. Did last year. Scale drawing, yeah, we did. It shouldn't be too much of a thing. All right. Yeah, you did last year. Did last year. The same thing can apply to our things, to our pin joints, right? Just Remind you, right? Right. I'll open. I'll do an example on you, right? And somebody can sketch on you. Right? You have to sketch like I've done, right? I'll have to sketch it. I'll let somebody sketch it, right? So whoever's going to do it, anybody want to have a go with this? All you're going to have to do is just sketch like I've done, boys, right? Don't draw it properly because you can't. You haven't got a protractor unless you've got one at home. But I'll open the board up and somebody can sketch it, right? So if I've got, that's me there, right? ML. I'm being pulled that way at 7 newtons. I'm being pulled that way at 3, and I'm being pulled that way at 4. Right? So, does anybody want to sketch this? Anybody want to have a go at that? Wait there, let me just give you some angles. So this could be in here 30 in there, look, that's 30 in there. This could be 80 in there, look. And this could be, say it's 20 in there. So calculate resultant force. Calculate force and angle. Who wants to go do this? Because I don't want you all to have a go. Who wants to have a go? Anybody have a go? Joe Brown, Sam Houston, Kieran Monfort, have a go? Somebody draw Howard, draw the 7 then first. Draw on there now if you want to. Sketch it on there. I don't want you to draw. It's not going to be done properly. Just sketch it. 1 centimeter equals 1 newton. Somebody sketch it. Anybody? 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 Nobody. Come on, Joe. Joe Brown. Anybody? 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 Well, so you do the 7. How would you draw the 7 newtons? Go and pick on somebody. Ethan Thomas, Jack Atherton, Joe Brown, Josh Rogers, Carl Cook, Mark Thomas, Oliver Booth. 7 centimeters here. Well, sketch it on there, please, Kieran. Sketch it on there. Correct, 7 centimeters at an angle of 30, right? The 7's an easy one. 7's an easy one, isn't it? There we are. 7's an easy one, right? That's the first one you do, right? Put the angle in there, Kieran. Put the angle in there, Kieran. Put the dotted line. So you would draw exactly like that. You'd make it 30. Like that, all right? 30 in there. And then you would put 7 centimeters. Somebody else can do the 3 then. Who wants to do the 3? Somebody ever go to 3? Somebody ever go to 3? Bearing in mind it's 80 degrees, right? So you want to put it on the end here now. Sketch it what it would look like, right? You're going to do it, Joe. Just mark in where the angle would be. Yeah. Oh, we're a bit tight now. We're a bit tight, you know. Let me get this right. Is that right, that angle? Really, it should be 80 degrees, right? So it should be this. You put that, you protractor on there, look, and you'd measure the 80 would be here, look. There's 80 in there, look. Your line looks like the next is 80 in it. There's 90, right? But it would be in there. It wouldn't come from here. What would that be in there, though? What would that be in there? That's got to be about 100 in. That's got to be 100 then, it really. So you draw that, right? So it's 80 degrees where 80 is. Right, 90, yeah, okay. And then, which line should we use? Let's use Right, so you get it right, get the angle right. Got the angle right. We'll use, hang on. Let me just rub this here a bit. Because now I'm panicking a bit now because we haven't got enough room. Right. So 80 in there, 80 in there. I reckon this line is a bit more 80. The line originally drawn was this looks a bit more like 80 to me then. Perhaps 80 degrees, perhaps. Right. But if you get the angle wrong, see, or you haven't got a protractor, you're not going to be able to have a go, right? So obviously it'd be 3 centimeters, and then the last one would be what? I'll do it because it's hard now because we haven't got a thing, we've got enough room. But you would now draw this 20, right? So that's 3. You'd then have to put your protractor on here, like that, and measure 20 degrees. So you'd have to measure 20, which would be about there somewhere, say, yeah? Right. And then your line would get messy now. It's not very clear, is it? Then your line would be like that, look, thick line like that. 4 centimeters. 4 centimeters. Run out of space. But the angle in there would have to be 20 degrees in there. All right? So we've got 3 lines then. We've got 3 lines. We've got this line coming up. 7 and 30, and then we've got 3 coming up, 80 degrees, right? That looks a bit more like 90, doesn't it? But it's 80, right? And then 20 degrees would be in there. You draw 4. You would draw 4. The angle in there would be 20. Then the final resultant force would be all of this. And the angle would be, I would do it in there. Angle would go in there. Everybody all right? Right, it's just a bit tricky. Make sure you get the angles right, right? Make sure you get the angles right. Right. Without drawing anything, right? Because I've got to go to the toilet. I'm dying to go to the toilet. Without drawing anything, right? Go to the toilet, boys. This is, I don't know, Joe Brown. Right. That's 7 newtons. That's 7 newtons. And that's 3 newtons. Sketch that while I go to the toilet. You don't even have to sketch it to know which way he's going to go. Which way would you go? Because the 7 and the 7 are going the other, right? So you'd find they cancel each other. I'm just going to go to the toilet, right there. Talk with yourselves. Oh, clip it now. I'm back, lads. Just hear me. Just hear me. Yes. Right. Obviously, something like that. I wouldn't give you something like that, but I thought while I went to the toilet. Obviously, with this one, you would draw the 7 that way, and then you would draw the 7 back. Then you would draw the 3 up, wouldn't you? So that's how you would do that one. But it's just a little one. Is everybody all right there with this drawing stuff? Because you need to be doing it sometime, all right? But you need a protractor, and a compass, and a ruler. Right? You definitely need some of them. Now then, I'll do it. Right? What's time now? 1:30 we finish it. 1:30 we finish it. 1:30 finish it. 1:30 finish it. 1:30 we finish. Is that past we finish? Right, let's just say, for an example, just you might get one like this. Now, if I've got, let's say we've got this. Let's just do this for a laugh, right? Let's make some numbers up here. Make them up. Say if I had this pin jointed frame we've been doing before, because you're going to have to scale draw this, right? Not only are you going to have to do it mathematically, right? Some people find it a bit easier, but you're also going to have to scale, work these forces out using a scale method like we're doing. So you could have something like that. There's your pin jointed frame, for example. Okay. So we need to work out now. Let's say we've got a force here. Let's say we've got a force here. Let's say it's 10. We need a force coming down, 10. 10 kilonewtons, huh? And we need to work out, let's say we need to work out this force in here, F1, and we need to find F2. And I need to give you an angle. Now, it's slightly different to what we've done before because we haven't got F1 and F2. So we're going to have to draw, right? We're going to have to do a bit of drawing lines. We don't know the length of, but we know the direction, right? So we know the direction of F2 and we know the direction of F1. So say if we had to draw this now, right? So say if we wanted to find what F1 is and F2, all right? That's going to be my joint. Let's say we've got 10 coming down by there, down by there. All right. Got Neil Buckland in the room with me. Remember Neil? Did you have Neil Buckland last year? Yes. There's F1 and there's F2, right? So we're going to draw now a scale diagram to find F1 and F2. What are we going to start with? What is the only one we can start with? There's only one thing we can start. Only one force we can start with. I'll never tell what it is. There's only one force we've got. We've only got the 10. All right, we've only got the 10, so we've got to start with the 10. All right, we've only got 10. Okay, so you would do this. I would start off. Now the 10 is coming down, right? So I'm going to draw a line now, equivalent 10 kilonewtons. So what scale should I use? Well, I might just draw, 10, 1 centimeter equals 1 kilonewton. All right, you've got to come up with the scale. All right, and I'm going to say 1 centimeter is 1 kilonewton. So I'm going to be drawing 10 centimeters, right? So what you would do is you do this. You would draw a line now coming down. I left listening to me now because it's quite hard to not explain it, but physically doing it a bit better. Right? But I'm going to draw a line now, 10 straight down, because that force is coming straight down. I've got to start with that one because I've only got that force. So I would draw a line. I would draw it straight down. If I was you, I would just perhaps even do like a little datum there, right? This is where your little graph paper would be handy. Right, straight down, right? And it's going to be 10 kilonewtons, which means it's going to be 10 centimeters. So 10 centimeters is going to be 10 kilonewtons, because 1 kilonewton is 1 centimeter. So I'm going to do 10. So you would draw down 10 centimeters. Draw down 10. Stop. Right? Now, I would also do this because you're going to need a little datum in a bit. Right? So then I would draw a little line like that. Right? Now, we don't know the size of the other two forces. We don't know the size of the other two forces, but we know the direction, right? We know the direction. So we're going to complete the triangle now. Do we know the direction of F1? Yes, we do know the direction of F1. Right? It's coming like this. Right? So The drawings will tell us now if it's a strut or a tie, because it'll tell us the direction. So I know that F1 is coming up. Don't know by how much. So I'm just going to draw a line coming up like that at an angle of what? What's the angle going to be? Well, the angle is here, look. It's 30 from the horizontal. I don't know how long F1 is. I don't. But I know its direction and I know it's 30. So what you do is you do this. Draw a line from here. I'm going to draw a line. What you do is, get a ruler and you measure in here 30 degrees. Right? So off this line, measure 30 degrees. Say it's there. There's 30 degrees in there. There's 30 degrees in there. And it's coming off like that. Right? It's pulling on this joint. Right? But the vector forces, right? So we've got 10. I'm going to add on this F1. So I'm going to add on now F1. I don't know how long it is, but I'm just going to draw a line like that. I don't know how long it is. I don't know how long it is. Right? But I know its direction. I know it's F1. I know it's going that way because I'm joining up I'm just adding up the forces now to each other. We've then got to close this thing. Right? We've got to close it. Right? We've got to close this triangle. Okay, I've drawn F1 as long as I want. As long as it comes past here, look, there's the clue. I don't know the size of it. I know the direction. If I do, it's 30. Now the last one, I've got to close this polygon. Now I've got to close the triangle. F2 is going straight. F2 is going straight. I don't know how long F2 is, but I know it's going straight. So I just draw a line now. Draw a line to complete this. So what I would do is I would get a ruler. I would make a point there like that, and I would draw that line like that. That's coming up, that's coming across. That's F1 and that's F2. And then you would measure F1 and you would measure F2. So F1 could be, I don't know, say it's 10. That could be, I don't know, what could be there. So F1 could be, let's say, 20. That could be 20 centimeters. If that was 20 centimeters, how much would it be? I don't know what it is. I haven't worked it out, but I'm just scared. But you'd measure it. You'd measure this line. If it was 20 centimeters, what would the force be? Because don't put 20 centimeters. You've got to put what? It's going to be 20 kilonewtons. All right. So, all right, when you measure it, get your scale right, and then I would measure F2. Let's just say looks a bit less than 20. Say it's 15 now. All right. I don't know what these are, boys, because I'm just 15. If that was 15 centimeters, F2 would be 15 kilonewtons because 1 centimeter is 1 kilonewton. And that would be your forces. That would be F1 and that would be F2. F1 and F2. We could work them out right now if we wanted to. Work them out, couldn't we, if we wanted to. You could use a bit of sine and cos to work that out properly, because I'm just guessing what the numbers are now. Everybody with me? It's the same thing sort of, because we haven't got F1 and F2, we've got to draw lines, right? We don't know what these lines are. This F1, we didn't know the size of it, but we knew the direction. Same with F2, we didn't know the size of it, but we knew the direction. The only number we really know is the 10. And then we've got to draw lines, and then where they meet, that's where we'd measure. And that'd be F1 and F2 then. Everybody right? Everybody right? Everybody right? Type T if you're okay. If you've got a protractor, if you're doing this now with a ruler and a graph, it might be easier. So that could be one way of doing it. we could also have, right, one here, say. Let's say we've got another one here, right? Let's just, what we'll do is let's just rub this out a bit now, right? Is Jake back yet? Where's Jake? This is important. Is Jake here? Because he's missing it now. Where's Jake? Still can't get in, can he? Let's just say now, for example, we've got a force here. Look, so you always need a force from somewhere. If I don't give you a force, we can't do it. Right? Let's rub this out. Right? Let's pretend that we don't know. All right. Just go the other way. All right. Just a bit of practice. What's that? Because we change the part of it. Same thing, right? Just a bit of practice for you. Let's just say there's a 30 in there. Again, I don't know why I did that for, right? We'll call this F1 and we'll call this F2. Let's say this is 20 kilonewtons coming down, right? Same thing, but it's going to be slightly opposite now, isn't it, really? So we would then draw, all right, 20 kilonewtons. So I'll do the same thing. 1 centimeter. So I will draw a line now because we're going to draw this. So now we've got this now. We've got this, got that, we've got this. Right, so possibly got that, plus like that, and we've got something like that going that way. So now we're going to draw F1 and F2. There's my 20 coming down like this. So we would draw just like this one, but we would draw 20. So we draw 20 coming down like that because we know it's coming down. Right, we know it's coming down because it's this one here now. It's 20. No, we know it's coming down. We know F2 is coming up. We know it's 30. So you do the same thing, really. Right. We've measured 30 in there like that. And because we know that F2 now, and this one's coming up at 30, we will draw the line just like we did. We don't know, right? But we know how long, we don't know how long it is, but we know its direction. So you just draw a line as long as you want. As long as it's 30 degrees. As long as you make sure that it sort of goes past that, because we're going to draw. So there's F1. And that way past. And then the last one. Oh yeah, that's F2 in this one. That's F2. That's F2 then. And then we know F1 is coming straight. So what you would do is just like we did on that one, you would then get a line. Dot, 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 dot. So it's in line with that. You're going to close it, and then you would just draw that. And that would be F1. So you'd measure that then. So you'd measure this. You'd measure that. That'd be the force, whatever that length comes to, and you'd measure that. And that'd be F1, whatever the length comes to. Make sure that you convert it back into newtons. Is that all right for everybody? Let me know. Let me know. Type a yes. It's not hard, but it's just a bit more because we're not actually doing it, so it's just sketching at the moment. Sam is joking, I suppose. I will point you to a video in a bit. I've got a video on this or scale drawing on my YouTube channel. I did for my level 2s and level 3, so it's something that. So we could have something like that, right? And then the final bit that we could have. Right. So we could have a situation perhaps. Let me just make this now so it makes a bit more sense. Right. So we could have something like this now. We could have, let's say we had this, right? Let me just draw something here because we might get something like this. Let's say we've got something like this. Like that, right? And let's say we've got this like that, right? And something like this, right? So this triangle now is attached. This could be a wall, right, or something like that. It could be a wall. Okay. And let's say that we've got a force. Call it, I don't know. $50 kilonewtons there, right? Let's say it's got 50 kilonewtons there. So we could then work some of these out, couldn't we? We could work this out. We could work this out, right? And let's say we need to work these two out as well. Now, let's assume, right, never assume things though, right? Never assume things. Don't forget, with something like this, right, it's pulling, so this is meant to be a wall now, right? So obviously, if it's coming down like this, trying to pull it off the wall. So these could be joints like, stuck to the wall. So these could be bolts, right? Now, don't forget, what's stopping whatever this thing is coming off the wall? There's a force coming, there's a force trying to pull this off in there if this was something, right? So there's got to be what here? Got to be, what's the word I'm looking for? Begins with R. What stops that coming off the wall? What has there got to be going this way? What has there got to be going that way? Stop this thing coming off the wall. Got to be something going that way. What's going that way? Not a trick question, it's not a trick. One force going that way, which means we've got what going the other way? Come on, Heath. Somebody guess this word. Somebody guess it. There's got to be, as you're all sleeping, there's got to be a force going that way, isn't it? There's got to be a force going that way to keep this thing up. Because there's a force going that way, trying to pull it off. So it means there's a force going that way. So we'll call it a force. What's the real word that we call it? It's not going to be quite 50. That's called a reaction, right? Right, I'm just trying to, right? Because don't forget, we have got a force, so we have got reactions, right? So we have a force in this. Let's just pretend, let's just make something up here, right? Make something up here, because I haven't got a scale drawing. Let's make something up. Let's just say it's, I don't know. Let's say the reaction here, right? It's 50 there. It's not going to be 50, right? Because 50 is going to be over these two, right? So let's just say, yes, there, we'll move it. Let's just say, because it can't be 50, because it's got to be over these two. So it's going to be less than 50. Let's say it's 20 kilonewtons. Let's say it's 20 kilonewtons going that way, right? I'm just, right? Now, if it's 20 kilonewtons, which we could work out if we did at the proper, if we had distances, we could work it out, right? Which we'll do next week. If I've got 20 kilonewtons going that way, bearing in mind every action is an equal but opposite reaction, what could I say is the force going that way in that little bit there? So 20 going one way, for things to be in balance, every reaction is an equal but opposite reaction. What could I say F4 is? 20, yes. Along with that, there's 20 going one way, which means for this thing to be in balance, is 20 going the other way. If it was more than 20, it'd be pulled off the wall, wouldn't it? So we could say we got 20 going in that direction. Could do, could do. Could do. Right, so it's pulling on that one, so really it's pulling on this one as well. Right? So we could say F4 and we could say that. Now, so we already perhaps know right now, it's not going to work out properly because I'm sort of guessing these numbers, right? But F4, let's say we say F4 is 20 kilonewtons. Right? So we know that one. Because we may have worked this out, or you may have been given it. We need to find now, let's call this F1 and we'll call this one F2. Now we can do that quite easily. We've done before. So say if I knew what them numbers were, I could now draw them. So I could find this quite easy. We'll just do this as a bit of practice. Because it's time to go in a bit. Right? So I could draw now. So I know what F4 is because I've worked it out. It's got 20, 20, 20. Right? And I know now that I can work these out. So I will say 1 kilonewton is 1 centimeter, perhaps. Perhaps not. It'd be massive, wouldn't it? Let's say 10. 10 kilonewtons is 1 centimeter. So 10, so we've got 5. Okay, so I would draw, let's say this is, what should we say? 30 again, let's stick to 30. Not going to be 30, is it? Because let's say it's 30. So I would draw a line now. We've done, right? Same thing as before, exactly. We'll draw a line down. How long would it be? Well, it'd be 5. 5 centimeters down, like that. And then I would draw F1 up. And forget, I don't know how long it is, but I know it's 30 degrees. So I get a bit of datum going, like the word datum. I would measure 30 by there. And I would draw a line, as long as we want, as long as it's past this point here. 30 degrees. We don't know, right, it's F1, so we'll label it F1. We don't know how long it is, but we know its direction because we know there's the 30 in there. And then F2, the final bit like we've done before, F2 is straight. So to close this triangle, you would then just draw F2 there. Going that way, that's going that way. And then you would measure F1 equals something, and you'd measure F2 equals something. But you'd measure here. So next week, lads, you need to get a compass. Sorry, not compass. You need a protractor and a ruler. Because next week, it's quite hard to do this. We're just sketching like this. We'll have to do it properly next week. So make sure you get a ruler next week. If you're in, when are you in tomorrow? You should have a ruler at home, and you need a protractor to measure angles. Otherwise, it's going to be sitting there, and it's not going to be any good for you. Have you got a protractor at home? You should have one. You need to get a protractor. Are you with me? Are you with me? Are you with me? Type P for protractor, if you're with me. Type P for protractor. All type P. All type P. All type P. Right, it's time to open it. Right. So then once we've known what these numbers here are, we could then work out this number here. Because we know this one, we know this one, and we know this one. Right? Then it's just a matter then of just scale, drawing this again and to find F3, right? But we'll do that next week now. Any time to go. Let me do a poll just so I know who's here. Let me do a poll. Is he still frozen with him, is it? Let's do a poll. The question is, are you still here? Are you still here? Yes or no? Are you still here? Yes or no? He's not on here. Okay. Josh Rogers, are you still here? Sam Houston, you still here? Sam Houston, put a yes. Put a yes. Sam Houston, put a yes. Can you tell Sam to put a yes on his thing, please? Sam Houston, put a yes. Sam Houston. Can somebody text Sam, please? Has he gone? I know he's here somewhere. Sam Houston. Sam Houston. Where's Sam Houston? Oh, he was here a minute ago. Right. You need to bring on the toilet. Okay. I know he's here anyway because he typed in there. The evidence is there, so cool. On the toilet. Well, yes. We've all got to go every now and again. Right. So next week, lads, it's better if you've got a protractor and a ruler. So next week you need a ruler. You should have one anyway. I don't know why I'm asking. You need a ruler and a protractor. Protractor to measure angles. Otherwise, it's just sketching. It's not very good. Deal. You need to get one. Hello, Sam. We're back on. You need to get a protractor. Can we all type D, please? If you're going to get me a protractor and a ruler next week, all type D. All type D for protractor next week. All type of D, protractor next week. All type of D. Miles Thomas type of D. It's a bit pointless otherwise. It's quite hard to do it without the D. Right, we'll do a bit more next week then. Hopefully we finish this off so we can start something else. So if everybody's happy, we can log off. It's 1:15. Go off and dinner. Make sure you get a protractor next week. It's a bit easier. This might have recorded, but I'm not quite sure the sound, so it might just be quiet. There is videos on my YouTube channel about scale drawing. We've all got now.